Hello students, welcome to you on online platform KVS RO Jaipur region and myself Suresh Kumar Yadav, PGT Maths Kendriya Vidyalaya Churu. I am here for mathematics video lecture and chapter is real number. First chapter, real number. In this video we will discuss about real numbers and their properties. For going on real number topic, real number, we will go through, that is recapitulation, means in class, before class 10th we have read about that. That is number system means we have read number system, natural number, then whole number, then integer number, then rational number, then irrational numbers. So natural number means which will start from 1 2 3, that is in using of counting 1 2 3 4 and so on. Whole number means if we include 0 in natural number, that is 0 1 2 3 and so on, this is whole number. And next is integer number, that is 0 1 2 3 and -1 -2 -3 also, that is negative and positive numbers, whole number, integer number. Next, rational number means a number which can be represented in the form of p upon q, where q is not equals to 0 and p and q are integer numbers. And irrational number means a number which cannot be represented in the form of p upon q, that is root 2, root 3, root 5 and so on. So this is our recapitulation. It means already we have read about this. Now in real number, first topic is Euclid division lemma. Euclid division lemma, it's not a new for us, Euclid division lemma, since we know that dividend equal divisor into quotient plus remainder. In class 6 7 8 we have read about this. Dividend equal divisor into quotient plus remainder. Dividend equal divisor into quotient plus remainder. Let's an example. When we divide 28 by 3, 3 9s are 27, remainder is 1. Therefore 28, we can write this 28 3 into 9 plus 1, that is dividend equal divisor into quotient plus remainder. So this is according to Euclid division lemma. Euclid division lemma means given positive integer a and b, given positive integer a and b, there exist unique integer q and r satisfying a equal b q plus r. That means if we divide a by b, then quotient is q and remainder is r. Then we can write dividend, this is a, equal divisor b into quotient or plus remainder r, that is a equal bq plus r, a equal bq plus r, where r means remainder is less than b and greater than equal 0, less than b and greater than equal 0. How? In this case 28 divided by 3, let us 28 means if there is 27, then remainder is 0. Now if there is 28, then remainder is 1. If now there is 29, then remainder is 2. If there is 30, then 10 3 tens are 30, 3 tens are 30, then remainder is also again 0. It means remainder will be 0 1 and 2, 0 1 and 2. It means remainder always will be less than quotient, less than divisor, remainder always will be less than divisor and greater than or equal 0. So we have divide 3 by 3, 30 by 3, the remainder will be 0 1 and 2. So therefore remainder is always less than b, b means divisor, and greater than or equal 0. This is Euclid division lemma and Euclid division lemma proved by Euclid, so it is called Euclid division lemma. Euclid division lemma, we know this from class 7th. Euclid division lemma means Euclid elements and Euclid algorithms. What is algorithm? Algorithm means a step. Algorithm is a series of well-defined steps. Algorithm is a series of well-defined steps, and well-defined steps मीन्स जो हम प्रोसेसर कर रहे हैं उसमें जो डिफाइन स्टेप्स हम डिफाइन कर रहे हैं उसकी जो सीरीज होती है उसको हम एल्गोरिथम बोलते हैं. और एल्गोरिथम इज अ वेल सीरीज ऑफ वेल डिफाइंड स्टेप्स विच गिव्स अ प्रोसेसर ऑफ सॉल्विंग अ टाइप ऑफ प्रॉब्लम. एंड lemma is already a lemma is a proven statement. Lemma is a proven statement used for proving another statement. मीन्स lemma is a proven statement जो ऑलरेडी प्रूव कर चुके हैं और उसको हम नेक्स्ट स्टेटमेंट को प्रूव करने के लिए यूज करते हैं, तो वो होता है लेमा. यहाँ पे हम यूक्लिड डिवीजन लेमा जो हमने पढ़ा उसको हम नेक्स्ट कहीं भी हम एल्गोरिथम यूज करेंगे. इट मीन्स वेयर व्हाट इज एल्गोरिथम, इट मीन्स देयर वी विल यूज अ सीरीज ऑफ स्टेप्स, एंड वेल लेमा मीन्स वी विल यूज एन प्रूवन स्टेटमेंट. यूक्लिड एल्गोरिथम we will use to find HCF of 2 numbers, 3 numbers. So for this let's take an example to find HCF of 2 numbers. Yes, we will use Euclid division algorithm to find HCF of 2 numbers. HCF means highest common factor. If there are 2 numbers, when one divided by other numbers, if remainder is 0, then smallest number is the HCF of both 2 numbers. Let us an example. Suppose 8 and 24. Since 24 is greater than 8, therefore we will divide 24 by 8. 8 3 are 24, remainder is 0. Then 8 is HCF of 8 and 24. 8 is the HCF of 8 and 24. If we take two numbers 10 and 24. Suppose 10 and 24. So to find HCF of 10 and 24, we will use division algorithm till we get remainder 0. So for this, we take an example first. Use Euclid's algorithm to find the HCF of 4052 and 12576. So since we know that 12576 is greater than 4052. So we will divide 12576 by 4052. So there are a long division method. When we will divide 4052 to 12576, 3 ja, the remainder is 420. So 12576 we can write equals to 4052 into 3 plus 420. So now divisor is 4052 and remainder is 420. In next step, 420 will be divisor and dividend will be 4052. It means we will divide 4052 by 420. So we will divide 4052 divided by 420. 420 9s and remainder is 272. In next step, in this step 420 is divisor. In next step 272 is divisor and 422 is dividend. 422 divided by 272, that is 1 ja, and remainder is 148. So in next step 272 is our dividend and 148 is our divisor, into then 148 divided by 272 divided by 148, 1 ja, and remainder is 124. In next step 148 is our dividend and 124 is our divisor, and divided by 124, the quotient is 1 and remainder is 24. In next step 124 is dividend and 24 is divisor. 24 5 ja 120, remainder is 4. Then last step 24 is dividend and 4 is our divisor. 4 6 is 24, remainder is 0. So last divisor is our 4. Last divisor is 4. So therefore HCF is, so HCF of 4052 and 12576 is 4. That is, with our last divisor will be HCF of these numbers. So we will use Euclid division algorithm. Algorithm means we will use a series of steps to find out solution of any problem. So here we have to find HCF of these two numbers. Then we are using Euclid division algorithm to find HCF. So our last divisor is HCF of these two numbers. Now example second. Example second is so that every positive even integer is of the form 2q and every positive odd integer is of the form 2q plus 1, where q is some integer. So in this example we have to show every positive even integer is of the form 2q and every odd positive integer is in the form of 2q plus 1. So 2q plus 1 and 2q. So let in the Euclid division lemma. In the Euclid division lemma, a equals to bq plus r, and we have to prove even integer in the form of 2q and odd integer in the form of 2q plus 1. It means let b equals to 2. So let b equals to 2, then a equals to 2q plus r. So r equal, that is remainder is less than b and greater than equal 0. It means r is greater than or equal 0 and less than b. B means 2. Therefore r equals to 0, 1 and only 1. 0 and 1, only 0 and 1 less than 2. So there are two cases. Then first case, when r equals to 0. Therefore a equal 2q plus 0. Put in this. A equal 2q plus 0 equals to 2q. It means when we divide by 2, then remainder is 0. It means this number is an even number. Since we divide by 2 and remainder is 0, that means this is even number. Therefore even. In second case, when r equals to 1, then a equal 2q plus 1. It means when a divided by 2, we will get remainder 1. It means this is an odd integer or odd number. So every even positive integer is in the form of 2q and every odd integer in the form of 2q plus 1. So we have proved. Now example 3. Example 3 is so that any positive odd integer is in the form of 4q plus 1 or 4q plus 3, where q is some integer. Here we have to prove every positive odd integer is in the form of 4q plus 1 or 4q plus 3. In the form of 4q plus 1 and our target is 4q plus 1 or 4q plus 3 and odd integer. 4q plus 1 and 4q plus 3. Since in Euclid division lemma we know that a equals to bq plus r. Then compare this. B is 4. So let a equal bq plus r. Let b equal 4. Therefore a equal 4q plus r. So r is 0, 1, 2, 3 less than b and greater than equal 0. So less than b means less than 4. Remainder will be less than 4, that is 0, 1, 2 and 3. So here there are 4 cases. So case first means r equals to 0. Put in this. R equal 0, it means a equal हो जाएगा 4q plus 0 equal 4q, and 4q we can write 2 into 2q, that is 2m. It means even number. Divisible by 2, m plus 0. Divisible by 2, remainder is 0, that is it's an even number. Case second, when r equals to 1, therefore a equal 4q plus 1, that is 4q plus 1, we can write 2 into 2q plus 1, that is 2m plus 1, where m equals to 2q. It means when we divide by 2, we will get remainder 1, that means it is an odd number. Third case, when r equals to 2, that is a equal 4q plus 2, it can be write 2 into 2q plus 1, that is 2m plus 0, where m equals to 2q plus 1. It means when divide by 2, remainder is 0, it means it is also an even number. It means it is an even number. Now last case when r equal 3. Last case when r equal 3. Case 4. When r equal 3. Therefore a equal 4q plus 3. And this can be write 4q plus 2 plus 1. And common out from this 2, 2q plus 1 plus 1. And now we can write 2m plus 1, where m equals to 2q plus 1. It means when divided by 2 and remainder is 1. So it is an odd integer. It is an odd integer. So in the 4 cases, we get when r equal 1 and when r equal 3. It means 4q plus 1 and 4q plus 3 are odd integers. 4q plus 1 is odd and 4q plus 3 is also odd. Therefore, we proved that any positive odd integer is in the form of either 4q plus 1 or 4q plus 3. And our last example, fourth is a sweet seller has 420 kaju burfis and 130 badam burfis. A sweet seller has 420 kaju burfi and 130 badam burfis. She wants to stack them in such a way that each stack has the same number and they take up the least area of the tray. What is the number of that can be placed in each stack for this purpose? So for this, we will find HCF of the number 420 and 130. So we will use Euclid division algorithm to find HCF. So you can do it. And exercise 1.1 also there are questions are same as example. So you will try. Thank you. All the best.